Hello everybody. Today we are going to be discussing section 1.4, velocity and speed. We need to begin by defining the term uniform motion. Uniform motion is anything that's moving at a constant speed. So motion diagrams or graphs of the moving object are going to be equally spaced because the displacement, I guess I should put a little vector here, is constant. All right, so some sample problems. If your choices are moving at a constant speed, slowing down, or speeding up, and you have the three diagrams listed here, 1, 2, 3. You are supposed to define which is moving at a constant speed, which is slowing down, and which is speeding up. In class, we decided that it would perhaps be easiest to begin by identifying which object is moving at constant speed. So if we go back to the definition here, it said that the motion diagram should be equally spaced because you're moving at a constant speed. So out of your three pictures here, the one that would be constant motion, oops, sorry, I gotta fix this here. The one that would be moving at a constant speed is the one where they are equally spaced, which would be this green diagram. So constant speed. All right, so that one would be the easiest. Now we're left with the red and the blue graphs. Which one is speeding up, which one is slowing down? All right, so what I had told my students in class is pretend like this is a car that is moving forwards and slowly dripping oil, like maybe one drop every, 10 seconds or 30 seconds. And this is what the road looks like underneath it. So if you look here at the red diagram, at first the dots are pretty evenly spaced, but then the dots start getting closer and closer together, which means that you're not covering as much ground in the same time frame. So in this 10 seconds, you didn't move nearly as far as you did in the beginning. So if you're not moving as far in the same time frame, that must mean that you are slowing down. All right, and we said because not covering as much ground in the same time. All right, so then this diagram, since it's the opposite where these dots are pretty close together and then they start spreading farther and farther out, that means you're covering more ground in the same amount of time. So if you're covering more ground, that must mean that you are speeding up. All right, so part of today's lecture is that I want you to be able to identify and explain different types of motion diagrams. All right, so our new concepts today are speed and velocity. All right, so speed is defined using the symbol a lowercase s, and it's the change in distance per the change in time. Now, distance, we had talked about in our last lesson, is a scalar quantity. So the only thing that you need to describe in order to accurately describe speed is just the magnitude of the speed. Velocity, on the other hand, is the change in displacement, because remember, displacement is the change in x per change in time. This is a vector quantity, so that means you have to give the magnitude and the direction. So you can't just say moving at 30 miles an hour, you would have to say 30 miles an hour east or west or north or south. Regardless, both of those quantities have SI units, meters per second. Other common units, though, would be like kilometers per hour or MPH, which stands for miles per hour. And I encourage you to write it as that rather than MPH when you're doing unit conversion. So you make sure that you keep the hours in the denominator and the miles in the numerator. Now, besides saying north, south, east, west, we generally will quantify using sign conventions of positive or negative. So a positive velocity is generally something that's moving to the right, up, east, or north. Negative velocity is generally to the left, down, west, or south, although you need to read carefully on each specific problem to decide what's happening. All right, so another way that we can diagram motion is by plotting graphs. Now, normally, you would plot the y-axis up here and the x-axis down here. But generally, we are going to plot position versus time, which means that x, which stands for position, is actually going to go on the y-axis, and time is going to be plotted here on the x-axis. Now, if you think back to your lessons in math class, slope is equal to rise over run, which is typically the change in y over the change in x. So on a position versus time graph, the slope becomes very important, because the quantity that's on the y-axis is actually position, or x. So change in x per change in time, which looks like a pretty useful quantity, because remember, you went back here, velocity is the change in position per change in time. So the slope on a position versus time graph will always tell you the velocity of an object. All right. So we analyzed some graphs today, because we will in class tomorrow be using motion detectors to try to match and simulate graphs. All right, so if we look here at the red graph, you have a position that is changing, all right? Like maybe we say that this is up here at the point 2, 2. So you've moved 2 meters in 2 seconds, and you started at 0, 0. So the slope of this line would be equal to 2 over 2, which is 1. So you do have a slope, which means that you are moving, you are changing position. So this would have a positive velocity, and it will be moving in the positive direction then. And the other thing that we can say is, since it is a straight line, the slope is constantly changing, so that means that you are at constant speed. Okay, so that graph right there is moving at a constant speed, because you do have a line with a slope, but it is at a constant speed because it's straight. So if we look over here maybe at the green line, again, you have a line that is moving. It's not staying flat, but instead of the position becoming more positive, the position is becoming more negative. So this is still moving. And you can even say at a constant speed, because it's a straight line. However, it would be moving in a negative direction. So maybe you're going from somewhere that's like 2 meters away from the motion detector towards the motion detector. So what about this orange line down here? This one right here, what's happening to your position? Well, like if this is a distance of 1 meter, as time progresses, you're staying at the 1 meter. So this means that the object is at rest because it has no slope. All right, the last condition that I want you to consider is this blue line here. And on the blue line, we don't have a flat line, so we know that we're moving. And we can even say that you're moving in a positive direction because the curve of the line is upwards. However, we can no longer say that you're at a constant speed because you have a curve. So not at constant speed. All right, so anytime you have a curve, you got constant speed. Anytime you have a straight line, anytime you have a curve, you do not have constant speed. Anytime you have a straight line, you have constant speed. And if it's a flat line, your object is at rest. The main takeaways from today are the differences between speed and velocity, knowing that speed is a scalar quantity and velocity is a vector, and also being able to analyze this type of motion graph or motion diagram where you just have dots, as well as an XY